Astronomy is one of the oldest natural sciences that studies the structure and evolution of the universe, including all cosmic bodies and systems beyond the Earth. It combines fundamental physical laws with practical observations of celestial objects, evidence object of study, cosmic bodies and phenomena. Date of origin: how science was formed in the ancient world. Main sections: astrophysics, cosmology, planetary science, celestial mechanics. The first telescope, invented by Galileo in 1609. Key methods: observations, spectroscopy, space missions. Application of knowledge: eclipse forecasts, navigation, space exploration, and technology development. The term astronomy originates in ancient Greece, formed from the words astron star and nomos law, literally the law of the stars. Astronomy arose from the practical needs of mankind. People observed the movement of celestial bodies in order to navigate in space, predict the changing seasons, and develop calendars. Some achievements of astronomy in the ancient world. In Mesopotamia, the Sumerians, Babylonians, and Assyrians developed the first star charts and calendars and created the lunar calendar. In ancient Egypt, astronomy was closely intertwined with religion and daily life. The pyramids were located on the cardinal points and certain stars, and the annual flood of the Nile was predicted based on observations of Sirius. In ancient China, the apparent movements of the sun and moon were so well studied that Chinese astronomers could predict solar and lunar eclipses. The ancient period. Astronomy achieved significant development in ancient Greece. Scientists not only observed the sky, but also sought to explain the laws governing the cosmos. Some achievements of ancient Greek astronomy: the idea of heliocentrism. Aristarchus of Samos proposed a model in which the sun is located in the center of the solar system and the planets revolve around it. The creation of the first star catalog. Hipparchus in the 2nd century BC indicated the exact stellar coordinates for about 1,000 stars. The geocentric system of the world. Claudius Ptolemy described it in his work Almagest, according to which the Earth is stationary and is located in the center of the universe, and all the planets, the sun, and the stars move around it. Astronomy has been developed in the Arab world. The main source of Arabic astronomy was the astronomy of ancient Greece, and in the early stages of development, also India and the Sassanid state. Some achievements of Arabic astronomy: the invention of the astrolabe, an angle-measuring device for determining the position of stars. The discovery and names of many stars: Betelgeuse, Rigel, Altair, Vega, and other names were borrowed by Europeans from Arabic. Compilation of star catalogs. For example, the Book of Constellations of Fixed Stars by Abd ar-Rahman as-Sufi, which contained the first extant description of the Andromeda Nebula. The Renaissance. European astronomy reached the Arab level in the 15th century thanks to the work of the Viennese astronomers Georg Purbach and Regematten, who relied on the works of astronomers associated with the Marijinsky and Samarkand schools. Some events and discoveries in Renaissance astronomy. The theory of Nicolaus Copernicus. He created a model of the solar system in which the Earth simultaneously rotates both on its axis and around the Sun. The development of accurate astronomical observations. For example, observations on the island of Ven helped to identify new stars and the movement of Mars. Influence on further development. The discoveries of Renaissance astronomers marked the beginning of the scientific revolution, which later unfolded in Europe and symbolized the beginning of the historical period of modern times. The ideas of Copernicus, refined by Brahe and Kepler, changed people's understanding of their place in the universe and led to the development of exact sciences, among which astronomy maintained leadership until the 19th century. Modern astronomy studies the universe and its objects, planets, stars, asteroids, and galaxies. Telescopes and spacecraft are used for research. Some areas of modern astronomy. Radio astronomy is the study of radio waves emitted by space objects. Optical astronomy is the use of survey telescopes to study light from stars and galaxies. X-ray astronomy is the study of high-energy photons emitted by space objects. Modern astronomy is a complex science that includes several interrelated areas. It is based on astrometry, the oldest branch that studies the position and motion of celestial bodies. Astrometry is divided into fundamental, which deals with determining the coordinates of space objects, and spherical, which develops mathematical methods for calculating their apparent positions. Theoretical astronomy focuses on determining the orbits of celestial bodies and calculating their future positions. This section is closely related to celestial mechanics, which studies the motion of space objects under the influence of gravitational forces. Astrophysics studies the physical properties and chemical composition of celestial bodies. It is divided into practical, which develops research methods, and theoretical, which explains the observed phenomena using the laws of physics. The main research directions of modern astronomy: astrometric observations, including the study of constellations and the celestial sphere; celestial mechanics, which calculates the motion of cosmic bodies; astrophysical research that studies the evolution of stars and exotic objects; galactic astronomy, exploring the structure of the Milky Way; cosmological research, including the study of cosmic microwave background radiation; planetary science, which focuses on the study of planets and their moons. The main tasks of modern astronomy are: 1. Determining the exact positions and movements of celestial bodies. 2. Investigation of the physical properties of space objects. 3. The study of the origin and evolution of celestial bodies. 4. Building a theory of the observable part of the universe. The solution of the first problem is based on centuries-old observations and the laws of mechanics. The second task was made possible by spectral analysis and photography. The third requires the accumulation of a large amount of data. The fourth task is the most ambitious, requiring the creation of new physical theories to describe the ultimate states of matter. In the 20th century, astronomy was divided into two main areas: observational and theoretical. Observational astronomy collects and analyzes data on celestial bodies, while theoretical astronomy creates models to explain cosmic phenomena. Modern theorists are working on fundamental questions of the structure of the universe using both analytical models and numerical modeling. The theory of relativity has become the key to understanding large-scale cosmic structures and black holes. The Landis-EDM model combines the concepts of the Big Bang, the expanding universe, and dark matter. Astronomy stands out among the sciences due to the significant contribution of amateurs. Enthusiasts observe the moon, planets, comets, and meteor showers, engage in astrophotography, help refine the orbits of asteroids, and discover new celestial bodies. The development of digital technologies has significantly expanded the possibilities of amateur observations. The year 2009 was declared the International Year of Astronomy by the United Nations, emphasizing the importance of this science for social development. Outstanding scientists and astronomers. Hipparchus created the first-ever star catalog and developed a system for determining the brightness of stars by stellar magnitudes. Nicolaus Copernicus revolutionized astronomy by proving that the Sun is the center of our system and the Earth is one of the planets orbiting it. Galileo Galilei, the creator of the telescope, used it for scientific observations for the first time. He discovered mountains on the moon, spots on the sun, and proved that the Milky Way consists of many stars. Johannes Kepler formulated 3 fundamental laws of planetary motion, which are still used in celestial mechanics. Isaac Newton discovered the law of universal gravitation, which explained the motion of celestial bodies and created the first mirrored telescope. Mikhail Lomonosov discovered the atmosphere on Venus and improved the design of the reflecting telescope. William Herschel discovered the planet Uranus and its moons Titania and Oberon, significantly expanding the boundaries of the known solar system. Edwin Hubble proved the existence of other galaxies and discovered the expansion of the universe, establishing a relationship between the distance to galaxies and the speed of their removal. Friedrich Bessel first measured the distance to the star 61 Cygni using the parallax method. Aristarchus Bolopolsky studied the rotation of the Sun, proved the meteoritic structure of Saturn's rings, and made a significant contribution to the spectral studies of stars. Each of these scientists has made an invaluable contribution to the development of astronomy, bringing humanity closer to understanding the structure of the universe. Their discoveries laid the foundation for modern astronomical science.